Get mask, ranges, how to verify the IP address, which class it is, what is network ID, what is the host ID. That part we will see now. Okay. So first of all, we went to what is an IP address. It's a logical address. Okay. It is a logical address uniquely identify a network. Sorry, uniquely identify a device in the network. It is that is what IP address is. Like I have a systems. Each system in a network should have a IP address. Okay. So one IP is different from another IP. Both are in same network logically, but so IP is different. So like we can identify each individual system with a different IP address. Like my PC is like a 192.168.2.224. My desktop is 192.168.2.211. So different IP addresses in the last first person is different, right? So like that, you uniquely identify a device in the network. So that is what IP address means. It's a numerical one. Okay, numerical one, not alphabetical one. It is a numerical representation. The two here. And who control this IP address and DNS names and all? The controlled by IANA icon only. Like you want to take a public IP address in India, a lot of ISP providers are there. So there are maintaining public communication IP addresses. What is the use of who will give that IP address range? So IANA only. Okay. So you can go to the Google type IANA. So you will get iana.org. So you can go through that website regional wise you can also check it. Asia specific, like different regions are there. So we have a two different versions of IP addresses, IPv4 and IPv6. IPv4 is released into the public earlier than IPv6, but they are made simultaneously. IPv6 has own benefits, but we are using IPv4 in a global communication. So IPv6 for a private communication means internal LAN network, and next depends upon the organization wise also we can use it, organizational wise or country wise also we can use it. For example, Germany, Japan, always competition in a technical way. So there are more to 5G technologies, IPv6 technology. Entire country maintain IPv6 technology. But when you say it's a global communication, so IPv4 only, because a lot of countries and a lot of organizations still their routers are supporting only IPv4, not IPv6. Okay, so we need a full upgradation of that one. Okay, of course, an organization is using IPv6. For example, in my company, I said use IPv6 only. But when I communicate outside of the organization, I need IPv4 communication, right? So of course there is a tunnels are there, IPv4, IPv6 tunnels. Okay, IPv6 to IPv4 conversions, ISA trap, ISA trap. So one of the server which converts IP, which make a communication between IPv4 and IPv6 networks. So different tunnels also there are using. IPv4 is a 32-bit, IPv6 is a 128-bit number. So when we are in a said 32-bit, obviously second one is 64-bit, right? But now here it is 128-bit. So be careful with that one. 2 to the power of 32 IP addresses, total IPv4 capacity, it means 4.3 billion IP addresses we are having in a IPv4. In IPv6, 2 to the power of 128, so 3.4 into 10 to the power of 38 IP addresses we are getting. So you can put a calculator also. So take a calculator and put here this number 2 to the power of 128. So it is nothing but billions of IP addresses, 4.3 billions of IP addresses. IPv4 generally represented in a decimal format. IPv6 is a hexadecimal format. IPv4 is divided into the four parts, means total 32 bit is divided into four parts. It means each part we are getting a 8 bits only. Each part we will get a 8 bits only, and it is divided by dot. Okay, this 8 bit is written in a decimal format from 0 to 255, means each part each part number from 0 to 255 only. Okay, you cannot get more than 255. For example, 300 is there, 400 is there, so this is an invalid IP addresses. That is invalid IP address. Even I have a hobby of watching these serials, usually old serials and new web series and all, not Hindi and Telugu, usually English, but I watch one series called Criminal Minds. Mostly the Hollywood means technically more accurate, right? But in that one I found they give more technical details, so like we can think there is very more accurate in technically. But thing is what happened, so one guy is telling an IP address of somewhere crime is happened, they have a computer, so they has to log in remotely. They said IP address of a computer, IP address of computer, they said 401.300.200.20. So I got out why 400 is came into IPv4. You got understand? So that is the wrong way. So in all octets you will get maximum number is 255 only. Of course there is certain other rules also there, we'll discuss that one also. Okay, so this one, each part we call it as a octet. Why? Because of it's a 8-bit number, and we written in a decimal format only. This is an example of IPv4. Okay, 192.168.2.114. Just for an example, just example how it is look like. Okay, in IPv6 is a hexadecimal number. Each hexadecimal in a binary it is a 4-bit only. So while you are writing an IP address of a IPv6, so you have to divide 128 by 128 binary bit, and 4 bit is 4 bit is a 1 hexadecimal, so it is a 4. So divided for 32 hexadecimals are there in a one single IPv4. Okay, 32 hexa. Okay, each number is a one digit. Each number is a one digit here. Okay, so out of 32, we are divide entire 32 into 8 blocks. 8 blocks. Okay, 8 blocks. So totally in each block we have a 4 hexadecimals. So this is like a 2002 1111 3333 A. Just for an example, I've written here. Of course, in IPv6, there is a few more things are there to write in. So different type of IP addresses are there. So we'll see that one. But now, just for an example, how it is look like. Next. In IPv4, you have a unicast, multicast, and broadcast, but in IPv6, we have a unicast, multicast, and anycast is there. So unicast is like a private IP, public IP addresses we are using. Multicast only used for a certain services purpose only. So we cannot say in that in a communication wise. It is in a different purposes, like different service purposes only. But here we have a public address, private IP addresses in the unicast. But in IPv6, we have a link local IP address, global unicast IP addresses are there. It is for a public communication. This is for a private, means within a LAN connection only. So private means inside of a LAN, not to communicate outside, means public, means internet. Okay, so public IP addresses are used to communicate outside of the internet. Next, we use 127.0.0.1 as a local host address. Okay, so I will tell what is local host address also. So that is the one, and here in IPv6 colon 1 as a local host address. This is my unicast IP address. This is for a certain services purpose. The reserved IP address is 0.0.0, and here it is colon or a colon 0. Next, this is a range of IP address in IPv4. We'll completely discuss IPv4 onwards here. So 0.0.0 is starting IP, and this is the end of the IP. It keep on going like this, like a 0, 1, 2, 3, 4, and once it is reaches a 255 in a last octet, automatically IP address is 1.0, 1.1, 1.2, 1.3, like that, 1.255. Next it is become 2.0. It keep continue like that. Next, already asked you question, guys, but today, okay. So why it is divided into the classes? Because we have a limit of IP addresses is 4.3 billion IP addresses. Okay, and we don't know which network and which user using how many, what kind of network you have. Sorry. Um, Division of the classes to make it more useful. Okay, and reserve division of the classes based on more useful and more reserve conditions. And the other thing is, on another hand, depends upon the network size, depends upon the network size. For example, in your organization you have a 100 pieces, so you have to use one kind of class. In an organization you have a 500 pieces, maybe in a one organization there is a 1,000 pieces, in another organization they have 1 lakh pieces. Got it? So like that, depends upon organization, different pieces are there. So if you keep on giving a one by one IP address to each and every PC, it can be finished by 4.3 billion. Think like that, how many organizations are there in this world, how many computers are there, how many mobile phones are there. So if you give one by one IP address, the IP address will be finished. And so that they're done class wise, and we can use more purposeful wise of this one. Okay, next, here, to identify what class IP address you are using by first octet of IP address, we can identify by first octet only. So when you write an IP address, see the first octet and we can identify which class it is. I will tell you subnet mask and all, but currently first we should identify which class you are belongs to it. I'm removing this binary thing, so then you can tell which class, what is the range of IP addresses and all. Class A, Class B, Class C are unicast IP addresses, and Class D is multicast, and Class E is R&D, means a special reserved IP addresses. Of course, here I told private unicast addresses private and public, but actually unicast address having no division, like class A, class B, class C IP addresses comes under here unicast addresses only. Actually there is no division of public and private in a unicast wise, but you have a private IP address and public IP addresses, but generally those are all in the class A, class B, class C only. So don't get confused. Class A, Class B, Class C are unicast IP addresses. Class D is a multicast IP address range, and Class C is a reserved for certain organizations or research purposes, research organization purpose, or maybe any special reasons it is there. Okay. So Class A range is 0 to 127. Class B is 128 to 191. Class C 192 to 223. Class D 224 to 239. Class E 242 255. Now I will ask any one of you. So just read the classes. So two I have to ask. So many people. Yesterday I asked Yash, right? So today we'll ask Vaishnavi. Okay. Vaishnavi, read the class and their ranges. Class A range, Class B range, Class C range, Class D range, Class E range.
Okay, sir. Class A from 0 to 127. Class B, the range is 128 to 190. Class C, 192 to 23. The Class D range is 224 to 239 multicasting. Class E, 240 to 255.
Very good.
Thank you.
So where one more person will take in upper list. Okay, last time I asked Ajit and Ajinkya also. So Ansu Mishra,
Yes, sir.
read class and ranges.
Class A range 0 to 127, Class B 128 to 191, Class C 192 to 223, Class D 224 to 239 for multicasting, Class E 240 to 255 for research and development.
Very good. Okay, that's so just for like I can't ask everyone, so I'm selecting one by one. Okay, okay, very good. Practice, guys. Others also read it parallelly. If someone is reading, does not mean you don't need to read. You can also read it parallel. Okay. Now, identification of IP address. I will give you 3 4 IP addresses. Identify and tell me which class it is. Anyone can able to tell answer. Okay. So everybody try. Okay. So I am giving like 130 dot 14 dot 200 dot. So I will give 191. Which class it is?
Class B.
Class B.
Class B. Very good. So class B IP address. Very good. How? First one is 130. That is only we said C. 130 is between 128 and 191. It is class B. Next, 90 dot. Oh, sorry. Dot.
Class
For,
A.
yes, it is a
Class A.
class
Class A.
A only. Very good. 90 means in between 0 to 127. It is class A only. 200 dot 200 dot 200 dot 200
Class C.
Class C.
Class
Class
C.
C.
class.
C. Class
Oh,
C.
very good, class C. So we'll get 225 dot 3 dot 2 dot 4 dot 4
Class D.
Class D.
Class
class
D.
Class D.
D. Very
Yeah.
good. This is how we can able to identify. Look at the first octet and check the range and find out which class it is. Very good. Here our network. Good. Here in our network, so each IP address is divided into network portion and host portion. Network and host portion. For example, already I told last class like a first floor. So 101, 102, 108, or 110. It is like that. It is now. So we can understand. Okay, these are all belongs to first floor. Okay. For example, I have things like 304, 305, okay, and 407. So what happened here? This is third floor. This is fourth floor, right? This is fourth floor. So like that, okay. So like this, we can able to understand which floor it is. Similarly, our IP address is divided into host and network. Okay. Also, already given an example in a pin number also. Which state you are belongs to it? Which state you are belongs to it? Right? Like that. So what is this plus 91?
India.
India, right? So it means like a country zone. So something somewhere we have to divide zonal wise, floor wise, state wise, country wise, continental wise. So different way we have to divide, so then we can easily understand, and we can easily said it is belongs to them only. For example, ECE people are there, triple E. Why we can't say all are BTech people? You know why we are telling no all are same people only, all are Indians only. Okay, but there is a division, right? So there is different divisions are there. Why can't you say everybody is a BE? Just university declaring he is a BE graduate without to specify the branch. Okay, so what will happen? We don't understand what you studied. Okay, what subject you studied? Person who is giving a job or person who is dealing with it, what you studied, we don't know. Why we should need a discrimination? Okay, we put a BE degree or BTech, okay, or BSc, all combined, bachelor degree, that's it, master's degree. Then you don't know. No one knows you have done a BA, BSc, or BCom, or BA, BTech. Okay, MBBS. You done a MBBS, like you are a doctor, and I'm a just a BA candidate. So both are equal now. Okay, both are having a bachelor degree. Both will do operations. So that's a thing. Okay, just for uh, the division and all kind of stuff. But here I'm going to IP address only. Just now only I got a thought that one. So why government is do better like that? So then no discrimination at all. Okay. So just for an example, my network number is one and host number is one. My network number is one and host number is two. My network number is one and host number is three. It meaning is all these three PCs are a same network, so then they can communicate each other. They can communicate each other. For example, I have a another network, so like two, four is there. Network is two, host number is four. Network is two, and host number is five, for example. So this is one logical network. This is other logical network. This logical network won't communicate with this one. Okay, I will remove this example from here. Okay, so this is like how IP address is divided into the host portion and network portion. But how to understand host portion and network portions, and based on their subnet mask. Subnet mask will tell you what is your host portion, what is your network portion. We'll see that one. So here we use unicast IP addresses for assigning IP address to APC. We don't use any other IP addresses, and there is a specific rules also there. First we have to go to rules of assigning an IP address. Okay, to assign an IP address to any adapter or any system, we should not assign 0.0.0 because it is a reserved IP address. What is a reserved IP address? For a particular purpose, reserved for a default rules in a networking, default routing, or reserved for DHCP client IP address, DHCP client. So when it is researching, different purposes it is using one. And also it is told that don't use zero series, means not only 0.0.0, also starting with the zero, don't use it. Okay, don't use, because it's reserved and we can't assign. Don't use means we can't assign. One second. Okay, very good. Next, 127.0.0.0, this is also reserved. Okay, this is also reserved. This is nothing but a loopback or local host address. What is a local host address? 127.0.0.1. Whether you get trained, not trained. This is a very common question in any kind of interview. Is what is your localhost address is 127.0.0.1. Usually to test your TCP IP means your TCP IP is working or not. The service, network service is running or not. Drivers are installed or not. Whether you are connected not connected. It is a self-test purpose. For self-testing and test for to self-testing and to test your TCP IP. So what to do? So go to CMD ping 127.0.0.1. So so it will tell you whether you are running with the thing or not. Okay. Okay. So this is a local host address. What is a local host address? What is my PC name? So I'll go to my CMD. This is my CMD. Okay. I put a host name. So my host name is this one. Like if I go to my desktop, I got my desktop. Some name is there. Like every PC has some name, right? So there is a unique name. Name is there for every PC. Like my name is Latif. Okay, your name is like Pawan is there, and Pawan is there. Sai Charan, Saurav, Gaurav, Ajinkya, Ajit. So that is names. That are the names. But every system has a common name. Okay, common name. That is called a local host itself. Local host means like a if I said myself means me. So every person himself is a himself, right? So like a herself or me himself or itself, like that we can say local host. What is a local host means it's a common name for every PC. My PC name is localhost, your PC name is localhost. I have a desktop that is name is also localhost. Every PC has its own name is localhost. And the localhost IP address is in IPv4 where it is 127.0.0.1. It means my PC IP address is 127.0.0.1 and your PC IP address also there is a IP address called 127.0.0.1. Okay, my desktop local 127.0.0.1. Yeah, that is called a local address. So some people call that one as a local address. What is a local address? 127.0.0.1. But if I try to ping to my local host, it will show here because IPv6. If I disable IPv6, then I will get a 127 definitely. Okay. So I may not understand in one shot, but try once. What is the localhost IP address? This one only. Used it for self-testing or self-connecting purpose. What is the use? Self-testing purpose because it's also called as a loopback address. Because it's also called as loopback address, it is used for self-testing purpose and also for self-connecting purpose. What is a self-connecting? For example, I develop a website and I want to see my website in my PC only. Okay, so I will tell where is this. Okay, um, okay, so this is my PC and I develop a website. Just is a common example I'm telling. So I develop a website. So I made this one as a web server. So I have a web pages. This is a web server. I have a web pages. Now I want to open the web server with a IP address, right? So very simple way. I will type http colon slash slash 127.0.0.1 or I can put http colon slash slash localhost also. So I will get a website open in the screen because where is my web server? This is my web server. These are my web pages, and I want to open my website in my PC only. In my PC only. So I use the localhost IP address, or I use localhost name also. Okay, but this PC has a one IP address. Think like this PC has a one IP address. For example, just for example, I given 180. This PC has a IP address like this. So I can use like this also. I can use like this also. No, 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 sorry. 180. So I can use 127.0.0.1 or a local host or my IP address. If I don't have an IP address, no problem. Still I can use these things within the PC only. But I have another PC. Okay, I have another PC. For example, this is a PCA and this is PCB. PCB is a client. So PCB want to access the website. PCB want to access website. It will open the browser here. It will open the browser and put a http colon slash slash 127.0.0.1 or http colon slash slash localhost. So when you give like this, what will happen? It try to open a page in a BPC only. What will happen here? When you give localhost means this PC only. If you give localhost means this PC only. So where you said localhost or this IP address, that PC only, not any other PC. So this entirely belongs to this PC only, not this PC. When you type like this, http colon slash slash 192.168.2.180, just for an example. Okay, when you type like this, which PC it is now? When you type like this is belongs to this PC. Sorry, this belongs to this PC. I am trying to open web page of APC. Web page of APC. If I type like this, myself, this is belongs to B and this is belongs to A only. Okay. So this is equivalent. For example, you don't have a DNS here, but if you have a DNS, http colon slash slash A. This is also same. This is also same as you send a request to APC. Okay. It's sending a request to APC only. Got it? So that is the difference. Localhost means myself, itself, kind of stuff only. Here localhost means this PC only. Here localhost means this PC only, not other PC. Okay? So that is what we call it as a localhost. Okay? Localhost IP address is this one. So when you say loopback, it is loopback means self-testing, but IP address is same, so self-pinging purpose only. Okay? So this is also we cannot able to use it, and also we cannot use um, entire 127 series. Okay, so we cannot use it. We cannot use means we can't assign. We can't use means we can't assign to anyone, so it will throw an error. If you try to use it, throw an error. Next, One more IP address range we can't assign. That is apipa address. Is anybody remember what is the range? apipa range?
169.254.0.0
0.0
to
to
169.254.255.255.
this entire range we can't able to use in a network communication. So we can't assign this range also. Don't assign to any. Okay, don't assign as a network. So this range we can't use it. We can't use it means don't assign in this range. Don't assign in this range. Of course, already I told starting 0, but also I want to tell, but it is not purely applicable. Not all the condition. Okay, just generally, general idea. Last 0, better not to use it. Last 255, better not to use it. But whenever we go to different network types, and we can use it, but better not to use it in general because mostly we are using class C IP addresses. So better not to use starting 0 as 255. Okay. Next, it is a universal broadcast ID. Means with respect of what network you are using, but whatever the network you are using, or maybe if you don't have any IP addresses, okay, so this is like a broadcast ID. It is like a broadcast ID. So like a broadcast address, you can say a broadcast address, not a broadcast ID. You can say it's a broadcast address. Means I want to send a message to everyone. Okay, DHCP source address when it is discovering time. Okay, source IP. So whether I don't know. Okay, we'll see that one how 0.0.0 is there as a source address and how it is destination address. Later, not in DHCP only. DHCP is not finished. I told troubleshooting problems with the DHCP and working out DHCP only. I told complete DHCP we have to discuss in servers. Okay, guys, these are the conditions of a IP address. Of course, and next one is private IP address is also there. Private IP addresses are there. So first I will give you ranges of a private IP address in each class. This is the total range I am giving. This is the private IP address range in a class A from class A. In class B, 127.16.0.0 to 172.31.255.255. So B, class C. Why most of your networks are with this thing because it's a private IP address. So when you check your IP address, mostly it is 168 series only, right? So that is because of okay 192 168 series only. So what because of it is private IP address range. Okay, so why it is class C? Why we are getting only 192? Also I will tell. Class B, class A, private IP. What is this private IP addresses? Here I'm using my local network. Okay. What is the condition of these private IP addresses? For example, I am in a big office organization. Okay, this is my organization, and I have a switch. Okay, this is a switch, for example. Okay, because if you put a switch in a corner, we can't draw it normally. We have to put a switch in a corner only. Okay, all PCs are connected in switch first. Here no internet because I didn't put a router here, not it, or a modem or any external connection. I didn't put it. This is purely local, right? This is very simple LAN network. Is it right? So I am using a LAN network. This is the LAN. Okay. So in this LAN, whatever I use the IP address, we can use it. No problem. We can use any IP address in the LAN. Not at all a problem because you are not connected to outside of the network. For example, you are connecting to outside of the network using a router, and router is connected to your internet through ISP provider. Okay, through ISP provider you are connected. Mm. Next, okay, so internally we are using private IP address only. You must use private IP address. Okay, so we should use your yes, now it is correct. So internally I should use private IP. This is my private, and this is outside is nothing but a public. So inside is a private, outside is called public IP address. So inside you can use any IP address range, but that's I can so it's prefer to use private IP address range only. In a private, anything you can use it. Class A, class B, class C, 10.0.0. Series, or a 192.170.16.0. Series, or a 192.168.0.0, that kind of any series you can able to use it within a private. Okay, inside private IP address you can, but when you communicate outside you need a public IP address. But for public IP address I have to pay for a public IP address. If I want to use the public IP address I have to pay for public IP address. Okay, you have to pay for public IP address when you are communicating outside. So you have to pay for public IP address. But how to pay? You are not paying, right? You are using a private IP address locally, but you are communicating outside internet. So your ISP provider will take care of your public IP address. He will pay. He has some public IP addresses on his own. He will pay. Of course, there is a few techniques there to follow, but that we will discuss anyway. So, but here it is, your ISP provider will take care of your public communication. Means whenever you can make a whenever you establish a connection from your local to public, okay, through ISP provider. So once your packet is reached to ISP routers, then it's sent with a public IP address only. Send packet outside of the network with a public only. So I want to show you my IP address once again. CMD IP config. So this is my IP address, right? This is Wi-Fi IP address. Which IP it is? Private IP, because 192.168. This is my private. This is my router address. Okay, then how can I communicate? So I will forward my packet. For example, this is my PC. I forward packet to router. Through router will forward the packet to ISP routers. Okay, ISP send a packet outside with the public. So they will internally map this private and public IP addresses. Okay, they will map here and here also. They will map it and send to public. You know what is your public IP address? Just Google it. Type what is my IP address. What is my IP address? Okay, if you Google it, you will get a public IP address. I don't want to show you because we should not expose the public. Oh, no problem. No problem. Not at all about it. See, you know this one. See, now it is showing this is my public IP address. So 103.94.57.231. This is my public IP address. But actual my IP address is 192.168.2.224. Okay, that is my private IP address. But this is my public IP address. Google, when I connected to Google, Google don't know my private IP address. Google don't know my private IP address. Google knows my public IP address. And here, understand one thing. Okay, here try to understand one thing. These are all pieces, right? These are all pieces, and okay. If you check IP address, for example, this IP is 100. This is 101. This is 102. Last part only I am writing. This is 103. Every PC having a different IP. Just guess what you will do. How to check it? Uh, Go to CMD. You know your IP address, right? Check your IP address. This is your private IP address. This is your private IP address. Now I'll give you one simple exercise. Okay, to understand public and private IP addresses. First of all, check check your laptop IP address. Normal IP address means your local CMD IP config part. Next, in that one only, in Google, type what is my IP address. Next, then go to, if in case if you have anything like, go to any other laptop or desktops inside your home. Same network, must be in same network. Okay, check other laptop or desktops in your home. So check their IP address. Okay, and then go to Google. Type in that machine also. Try. Okay, try what is my IP address. So I'll check for others. Then check for others. So then it is, so we should use less text here. So check the local IP address and type in a Google what is my IP address, and go to other laptops, check the IP address, and also check for a what is my IP address. Yes, your mobile phone is also connected, right? So go to your mobile phone. Okay, check what is IP address from your router, and also go to Google. Check. Uh, so easy way is to check for mobile also. This is easy, right? In mobile phones also try. Okay, my mobile phone IP address, I will tell now. I'm checking because both are connected to same Wi-Fi. Okay, I can't show you the mobile phone to you because I don't know how to show from here. Settings, where is the settings in my mobile? Otherwise, I have to cast it. It may confuse my network. Okay, so Wi-Fi settings. Yeah, I got an IP address is last one 247 192 168.2.197. So as per me, as per I checked it. So this is private IP address, right? Now I'm going to mobile only, same mobile. So I'm going to Google Chrome or any web browser, no problem. Any browser, okay. Google Chrome. So many are open here. Go into new tab and I'm typing what is my IP address. And I got an IP address is 103.94.57. In my mobile phone I'm reading 231. So in mobile phone I checked it what is my IP address in Google, and also I check IP address in my mobile phone, inside my mobile phone Wi-Fi connectivity. This is it is showing. So then I'm going to here. Is it same? Both are same IP addresses. Okay, it should be unique, right? It should be unique, but I'm getting same public IP address only. Why? Because of this is a called as a technique. A technique. So this part I will go again. Okay, it means for internal communication we use private IP address. In globally when you are communicating we should use public IP address. But can you buy public IP address? Can you pay for public IP address for each public IP address? For example, I have a laptop, I have a desktop, I have a two mobile phones and one Kindle. Okay, these are my devices, important devices. So at least one, two, four, five. So five public IP addresses I have to buy. Can I purchase it? How can I purchase it? That's a different version, right? So what they are using, they use the ISP. ISP will take care of my public communication, and why we are getting single public IP for all the devices. The technique called PAT technique. They use PAT. What is a PAT? Port address translation. Port address translation, also called as NAT overload. Actual technique is NAT technique only, but they are overloading NAT condition, so then it become port address translation, because porting is using like one IP address. Wait, for example, this one sending a packet outside some public IP address, some public IP address. What they will do, they assign a port number here, some port number, for example 80, 80, like that. Just some port number, random port number, or a protocol port numbers, for example. Anything. Okay. So based on this, it will be mapped inside a system, and we can able to communicate. So I'm communicating with another one. The port is valid only till Same public, right? Like this. It will maps dynamically with your local IP to public communication. So it will map it. So this is a technique called a port address translation, also called as NAT overload. What is this NAT? NAT means network address translation. So what is the use of this NAT? So it maps local IP address to global IP address or a public IP address. Local means internal LAN public IP address. Okay. So also we can say maps a local private IP address to public IP address. Okay. So when you are trying to access the Google also giving Google.com IP address is there now. That is public IP address for Google. Internally, different IP address are there. Okay, that we will see later. Okay, that's the thing. Okay, not later. I will tell that one only. For example, here I told big stories, guys. So you need a patience. Okay, I have a PC. Sorry, this is my PC. Okay, one PC. When it is communicating, like this is also having an IP address, right? 190.168. For example, 110. This is a PC. Now it is communicating outside. Communicating outside. Okay. So what router will do in generally, router is also used for NAT network address translations. Okay. So what it will do, it will map to some public IP address. Okay, based on your some public IP. It's not in a private. So this list is in a your router only. So when you are sending a packet, packet went to router, and in a router it will check what is the IP address. This is the IP address, and it is mapped to this one. So send a packet like this. For example, any communication you have a to address from address, right? Any communication to address and from address like source IP and destination IP address. Okay, so here source IP is this one, and there is a some destination IP, for example google.com IP address. Source IP is this one, destination IP something google.com. You need a number. Okay, this is my PC and somewhere server. So this is entirely internet. Have a connection to router through switch or something, whatever it is, just connection. Okay, I have an IP address 192.168.2.114 something. Okay. So here in a router I put a public IP address to go outside, some public IP address I purchased it. So I'm sending a google.com. So find out what is a google.com IP address. Just for an example, we need some number. Okay, like I'm sending. So What is the source IP while you are sending from your PC? This is the source IP. What is the destination IP? This is the destination IP. Okay. Now request is sent to router. Router inside there is a mapping technique called a NAT, network address translation. So this is a local, this is the global, and it forward the packet to outside. Just understand in this situation only, plainly, very plainly understand. Okay, so don't try. So what is real time, not real time? So that's we will see it. So this is the NAT. So in a NAT, this is the local, this is the global side. So what happened? It is mapped to this one. Now what is the source IP? This is the source IP. What is the destination IP? This is the destination IP. Destination IP is not changing. Source IP, when you are forwarding a packet, this is the source IP and this is the destination IP address. But here, source IP is this one, destination IP is this one. Finally, you reach destination. Destination will reply to you. Destination also reply to you, right? So, what is the source IP? Destination source IP is that 142.250.67.132. This is my source IP. What is the destination IP? This is a destination 102.34.45.66. This is the destination IP address, not this one. This is the destination IP. So router received packet from the destination. From google.com, I received packet. What it will do? It retranslate. It retranslate and forward to this port directly. It knows what is the local IP address. It automatically translate and give it. So google.com knows our public IP address only. It does not know what is your local IP address. It knows your publicly connected IP address only. Whatever you use inside google.com, don't know. So this is called a NAT, network address translation. For example, if I have a more PCs, for example, we have a more PCs. I'm removing all the things here, extra things. That is enough. Not more than that it is removing. Okay, I have a three PCs for example, and for example, this is a 68. Some IP address. In NAT, what I am doing is I will assign for each a public IP address. In the router only, I purchase different IP addresses. Anything, no problem, because it's a public, no problem. So if you see better, I will give 16 only instead of 17. Okay. So what happened? This is mapped to this one, and in a router, is mapped to this one. I will better use color. So this is mapped to this one. This is mapped to here. So when it is communicating internally, this is the source IP, and when it is going outside, this is the IP address. When you are communicating with this IP address, so internally this is the source IP, but externally this is the source IP. So I'm mapping one internal IP address to one public IP address, external IP address, global IP address. So that is what we call it as a NAT. It means so local IP to global IP address mapping. NAT is like two types. One is static NAT, and another one is dynamic NAT. In a static NAT, so usually one local to one global, 1:1 ratio only, or we can say one private to one public only. Okay, so if you take two privates are there, two publics are required. Okay, so the only. But in a dynamic NAT is also the same, but if you have a more local, means less global. Just for an example, 10 local IP address, but 5 global addresses. But at a time, all local cannot access to global addresses. Okay, it means where is this? Here it is. This is my public IP, and I have some other public IP, and 102, 34, 45. Okay, 45, 77, or maybe dot 78, maybe 79, like that. But here I have a more local is there 115, 116, 117, 118, 119, 120, like this. I have so many local are there, but limited of public IP address are there. So whenever it's a dynamically maps. Now it is a not a sticky one. It's a dynamically maps here. 1142 this, okay, and 115 to this one, and 116 to this one, 117 to this one, for example. But what about these things? They won't access public. For example, 115 request is completed means session is completed, 115 section is completed, then others will get chance. Okay, others will get chance. Okay, everybody can able to get a network, but not at a time. Every PC will every local can get access to global, but not at a time. But not at a time, all local cannot access to global one. Okay, all local cannot access to global at a time. Limited global IP addresses we have public IP addresses, dynamic NAT. Okay, next again PAT. What is a PAT? NAT overload. Here it is almost say all local to single global. We have a multiple IP addresses. Okay, all local or a multiple local IP addresses with a single or a one or two global IP addresses we can able to send all at a time. All at a time. All at a time can access to global. Okay, all at a time can access global. Okay, so this is about your public and private and static NAT dynamic NAT, and PAT. PAT means port address translation, also called as NAT overload. So all local addresses is communicated to single public. Already I explained here. So how it will happens.
Hello.
Yeah.
So I just having question in for the flow of the packet. Like packet flows from the host, then through router it reaches ISP, the service provider,
Yes.
and then service provider to the server.
Yes.
So suppose I'm using my lappy for the first time, and the router is newly installed, so it is not having the IP address of Google. So suppose there are two sites with the same name. So how it will decide what site am I referring?
Two questions that is. Um,
Yes.
one second. I will go to first one. Second one you can ask again. So this is the router. Today only you install a new router, and your ISP connected. Like when you are sending a packet, this will be connected to your ISP, right?
Yes.
Now this ISP don't know about this router and IP addresses, translations, mapping. We don't know, right?
Yes.
Because it's new one. Yes, it is correct. But actually, and actually, it is not work like that. It is work like you have a user ID and password. Okay, so this is a user ID is created at ISP. How it is works, I am telling this, and also there put a password. Okay, in their software. So there is a different techniques to give internet service to public. How to give internet service from ISP to public? There are different techniques are there. That's the only one name I'm not able to recollect it. That is not MLP, not that one. So it is yes MPLS. MPLS. Maybe this is one. This is a MPLS multi-protocol labeling switching. It's a routing technique, telecommunication work, direct data from one node to next data, short path label, then a long network addresses, avoiding complex hookup. So this is the one technique. Multi-protocol label switching, MPLS switching is one of the thing. Frame relay, okay, different techniques they are using. MPLS is one of the main technique. Nowadays we are using MPLS only. So earlier days we use a frame relay in a different organization. Okay, frame relay techniques. I think you heard ATM, asynchronous transfer mode. Okay, so these are the techniques to connection between your ISP to here. Okay, so in ISP using that technique they use a username and password. So normally, so when you are just connected, when your switch router is on, when router is on, router is generally connected to some IP address. So ISP, their junction boxes are there, no? So lot of junction boxes are there. Okay, so through this one they will get connected. Okay, so I am not going into this one because I am not CC NP or CC IEP person. The basic knowledge only I have. Okay, okay, so this is a normal connection will be established. So because of through wire and all, finally a normal connection is there. But important is in router you given a username and password. This username and password sent to ISP. ISP verified your username and password. Once once it is verified, they'll give you a internet connection. Means it's okay. Let connect. So you will get IP address, of course. You will get an IP address, and it is okay flow. It is Whatever the local request you are sending, that is up to your router. Router will put it your request, your user ID and password, send it to your ISP. ISP they will take care now and send it. Your local IP means your 192.series, for example 114. This ISP also don't know. ISP knows one information: user and your router. Each router has a one unique ID. Each router has a ID. What ID it is? MAC address. Outside MAC address. One second. I will again go. So WAN connectivity, LAN connectivity. Two things are there. LAN to WAN, WAN to LAN will take care by our router only. Okay. So this is also lot of junctions. We don't get clear information here. You have to use DSL, ADSL, then only we can get it. See, this is a connection from router to ISP provider connection. This is my router to local connection. Can you see a MAC address here? Different from MAC address here. This is E0. This is E1. So this will identify, my router is identified, this connection identified to ISP, not this, only this. Okay. So they will identify what is the type of router it is, what is the name of router it is, okay, what is the MAC address, what IP address, what IP address it is using in WAN connection only, not uh, okay,
Okay, sir. Got it.
got it right, not complete WAN connectivity. So we are not participate in direct outside. It is limit is ISP only from our router to ISP. This
Okay, sir.
connection from there ISP to outside, it take care ISP, that public IP and all kind of stuff. And even our router don't have a WAN. Public IP is not there, na? Like that. Your public IP
Okay,
is
sir.
there. I opened something. Yeah. So I opened something, but like this. This is the gateway. Okay, this is the gateway. This is my private connection only. So this is router WAN IP address, and gateway means again ISP providers, that one, and their DNS servers. Good. Okay, so this is how we can able to establish connection. Fresh router. What is your second question?
Sir, I got the answer.
You got answer. Okay. Yeah, said like a two.
Actually, it was just uh, because of a single confusion I got.
Okay. Okay. So this is like websites are there. That is a different point. Okay. Public and private. Another confusion is there. So that is now we will get confused. Public, private kind of stuff. No problem. So we have a lot of confusing things in the thing. Okay. So for there is so many questions. Google is showing my temporary IPv6 address. Very good. For my both mobile and laptop public is IPv6. That depends upon service provider. Like Geo, I think a lot of people said Geo is IPv6 they are using. Okay, depends upon your service provider. You will get your IPv6 or mostly IPv6, IPv4 like that. But we have to check is for multiple device having a same public IP address or different public IP address. IP address is separate. Okay, Mayur asked one question. One person only having only unique one public IP address is right. No, no, no. Person don't have an IP address first of all. Device has an IP address. Of course, IPv6 came up. Maybe a person have an IP address also. Maybe in future, person to person, each person give a one IP address like that. No, no, my point is little bit different. Okay. Normally, um, I will tell one story, then you will understand. Not a story, direct point only. This is my network. Network represent usually when you draw something and say it is a network, it means it's like this only. Okay. These pieces are in network. Okay. If they are not connected to internet, so we don't worry about public or private thing. So you can use anything. We are communicating. Now we connect this thing to router to communicate outside, right? This network is connected and we are communicating outside. We don't worry about how we connected, ISP, all kind of stuff, leave it. I am having a system, I'm connected to my router and I subscribe to internet, I can able to open the page. Okay, so I can open the web page, I can read the things, or I download the internet kind of stuff. Okay, I can watch YouTube videos. Okay, so I'm getting. Okay, Siddhik asked one other question, so I will tell answer. So guys, here it is. This is internal network, whatever it is. I'm communicating outside using my subscription, right? What technique is a PAT technique? They're generally following it. Here, how it is works, we'll see. This is my some server, remote server. Example, it's a Microsoft or a Google. We are very favorite is google.com, right? I open a google.com. I open a google.com. What happened? See, from here, I send request. Request is finally go to the global net, right? ISPs, exchanges, routers internally. Finally, it reach google.com and google.com received my request. Okay, and send a response. It's sending a response. Okay, sending a response to our ISP and ISP to router, router to me. Okay, of course, because of this mapping and all. So from outside, I'm using a public communication and reach google.com and google.com understand your request and giving a reply to your public IP, and again it is maps into private. So then it reaches to me. I'm getting internet without with or without buying a public IP. I don't worry about the public IP address, but I'm connecting internet, right? So now here start try to understand. There is a two things I'm telling. One, in public there is a person, someone like you are there. I'm showing my IP addresses also, right? I showed my public IP address. I showed my private IP address. I should not show, but I showed it. Okay. So for example, you are there in an internet. You try to ping to me. For example, this is my PC. You want to send a ping request to me. For example, just ping. Open a CMD, ping to my IP address. To whom you will ping? My PC, right? Like this is my PC. This is my PC. You are trying to ping to my PC with a this PC IP address. This PC IP address only. You are trying to ping from your side, from your internet. So you open a ping and you type my IP address and your request. You try to go outside and drop the packet because I'm using private IP address here. My network, your network, some others network also same. So 192.series, 192.168.2.224, that kind of IP address in the world, so many millions of IP addresses, same series IP address is there. Same series of IP addresses are there in the world. Okay. Now you are trying to ping and it is because of private non-routable IP address. It is not route in outside. In publicly non-routable. So it drop. So to whom I have to ping? You have to ping to my public IP address. Now you can ping to my public IP. Ping request will go somewhere and reach to my router or maybe my ISP provider's router. You reach up to here. You reach up to here when you are trying to ping to my public IP. So I showed my IP public IP also, right? And I try to send a request. Okay, you send me a request to my public IP. It reach up to ISP providers. Then it check here in ISP from where the request to who is this person, because public IP is same for here, 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 and some other routers also. Maybe public router is there, right? So public connection is there. So other subscribers are there, right? I have a router. My neighbor also having a router. Maybe that my second floor person or third floor person also having same ISP connection. These are all taking subscription, right? So my ISP don't know who is this person. It is a one router only. That's it. You don't know who am I. You don't know who is this. 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 Because you are sending a packet me to my private, it won't routable. Packet drop after router. Okay. If you are sending to packet to my public IP address, my ISP receive the your request, but it don't know to whom it forward. To whom it is forward. I don't know. Very simple. I will tell. You're all connected to my network, right? So you're all connected to my network. So someone is spoken. I didn't see who is speaking. I don't know who is asking questions also. Who is giving answers also? I don't know. Why? Because of I'm in this screen. A lot of people connected. Almost 25, 30 people are connected. So what happened? I'm not seeing that person. I'm hearing voice only. Okay. So like that. That is not exactly point, but here it is. See, this is the point. ISP received a packet from this person. For example, Gaurav is there. Gaurav sent a packet with my public IP address. He knows my public IP address. He send a packet. The packet receive up to ISP, and ISP don't know this public is belongs to which one, me or someone or other PC or some maybe another PC, maybe another connection. You don't know. You drop the packet, or it as per the receive, it tell I received the packet. That's it. But it not reaches to me. Okay, packet won't reach to me. Packet reach to ISP only, but it not reaches to me. So that is one thing, one story. Now I remove lot of things. Okay, next I have a server. For example, I started practicing web page creation. So then I created a web server. Just for example, I created a web server. Web server is the best example for all networking, every example or situations we can give. I created a web server in my local area network. In local area network, I created a web server. So this is also having a private IP, right? Okay, this is also having a private IP address. This one. Okay, for internally, everybody can access this web page. Everybody can able to access this web page. Okay, everybody can able to access this web page from in a local. But this guy want to access the web page. They want to access web page through internet. For example, who is there? Tell me someone's name. Okay, who is asking so many questions? Tell that name. Siddiq is there. Okay, so Siddiq from his system, he tried to access my web server. He's trying to access my web server from his PC, and he tried to access my web server. How can you access it? If you use my private IP, you can't access. Okay, if you use my private IP, you can't access because it's non-routable IP address. If you use my public, if you use my public IP, right? From ISP, it's not forwarding to my PC because the public is not binding to one single PC. It is belongs to so many people. It is belongs to so many people, like a bus stop. Bus stop is belongs to everyone, right? Not for only this person or that person, college going person or a job person. It's not like bus stop is for a bus where bus will be halt for some time, right? So like that, ISP and you maintain multiple public IP addresses. Any IP when you are communicating. So shit, I took a lot of time. Sorry. So for example, guys, if I want to communicate outside because I don't have a choice, my ISP will map all the details to a public IP and send request so I can able to communicate outside. And it is giving a reply with the same IP, and based on that details, session ID and all, it will forward back to you. Okay. So I have a PC. I send a request. So based on my sending request, I'll receive my reply. Understand? Based on my sending request, based on the details, ISP map to some public IP, send outside and receive and map back, and I got it to my to me. Okay, so like that. But if someone is want to come inside, someone directly want to communicate. I didn't send a request, but someone in the internet try to access me. He cannot access. He cannot access. That is a thing in a public and private and our internet service providers. You can send a packet outside, and based on your request, you will get a reply. But someone want to access your PC directly with your IP address, they can't access. With your public IP address, they can't access. You must send a request. That's why, you know, our systems are not getting hacked, but our systems are getting hacked. Both the statements are true. How come? Because of, when you download a torrents or a key generators, cracks, or illegal games, um, dangerous websites. Okay, so improper websites. or what we can say, pornographic websites. Okay, different kind of torrent websites. So when you open it, you are telling, please come to me. You are giving a connection, and you download some application, you install some application, the application contains malwares and trojans. This establish the connection. Spywares establish the connection means you are accepting some package or application or a toolbar or a website or a picture. So you double click and you are accepting it, you are putting some application in your PC. That application or a service or a link give a establishment to others, so then you are already hooked and start accessing. So what happen in a hacking? So you are hooked to someone, you send a request without knowing yourself. Based on this, they have a path and they can able to send to anything to you without your permission. They can use your system like that. So normally we can't get a hack, but hacking is happens only because wrong uses of system. Okay, be careful. Don't open unnecessary links and all. Wrong websites, dangerous websites, duplicate websites. Okay, like that. Second, here Siddiq asked one question that is also important. It is, what happens if we can map our public IP address as our private IP address? Can we still communicate over network? Yes. Here is the thing. I have a public. I have a web server. This web server should access in a public. Okay. So last point, guys. This person want to access my web server from public. For example, Siddiq want to access my web server. He can't access directly. What to do? Consult ISP provider. Ask a public IP address. Okay. So actually you have to go to Ayana ICANN. Ayana. So get an IP address. I will give another one. Okay. So tell ISP. You can reach here or you can go to ISP. Ask public IP address and fix tell any request to this public IP. Buy a public IP address and for example 101.10.20.30. I purchase this public IP address. What I done? I purchase a public IP address and inform to ISP or ISP, if any request with this IP one, please forward to my PC only. You have to tell, this is a router and this is the PC, this is the IP address. Any request for this public IP address, please forward to me only. Please forward to me only. Like that, you can connect publicly. So NAT and PAD techniques also used for that purpose only. Actually, NAT technique use it to connect public with a public IP address. Okay. Otherwise, you can buy a public IP address through ISP, so you can access, you can give your web server outside also. That is it. We can map here. Okay. Of course, in a router also there is a few techniques are there. If you purchase a public IP address, inform ISP to forward public IP to your router. Then from router to your PC, you can able to map it. Okay. That is we have to agree with some few things with the ISP. That is up to normal home network, I said. But in a reality, this is your organization. In organization, you have a router and it is connected to service providers, and you will use a dedicated lines and public IP address directly. ISP provider will take care of normally public IP and all, but internally, but while you are communicating outside, okay, ISP will create a leased line, means it's a dedicated line from your organization to outside organizations, like dedicated lines are there, okay, a specific lines. You have a public IP address, so you can map inside of your router public to communication also. Believe it, this is become more and more boring. Just understand what is NAT: local to global communication, one local to one global, or a two local to two local, like that. Means each local IP is mapped to different global IP addresses. Okay, what is PAT? You can use all your local IP addresses to a single global IP address, like all private IP addresses to a single global IP addresses. Depends upon your ISP, so they will maintain this global IP addresses only. Okay, so this is it. I am getting bored, and I took lot of time for this one. So suddenly I went to this place.